All right, today we're going to talk about radicals in regards to using them to help us find lengths of sides of triangles using the Pythagorean theorem. So I know you've seen the Pythagorean theorem before, so this will just kind of be a quick refresher. Okay, now remember, Pythagorean theorem only works if you have a right triangle. So you're going to have your legs of your triangle. Those are sides labeled A and B, and then your hypotenuse is side C. Okay, now also remember, side C is the longest side of your triangle. Okay, so for example 1, determine whether the given lengths can be the lengths of the sides of a right triangle. All right, well, if my sides are 5 centimeters, 12 centimeters, and 13 centimeters, then I know that the 13 centimeters, this is my hypotenuse. So when I set up a squared plus b squared equals c squared, 13 is my c. So 5 squared plus 12 squared equals 13 squared. So this is 25 plus 144 equals 169. You add 25 and 144, that does give you 169. So yes, these three lengths can be the lengths of sides in a right triangle. Okay, we're going to do the same with B. So we have 3, 7, and 6 centimeters. Well, 7 is the longest, so that is what our hypotenuse is going to be. So don't just assume, oh, the first two are my legs and the last one's my hypotenuse. Okay, you want to pay attention to which one's going to be the longest side. So this would be 3 squared plus 6 squared for my legs equals 7 squared for my hypotenuse. Okay, so 9 plus 36 equals 49. Add that together, I get 45 equals 49. Well, of course, that's not a true statement. So then, no, these sides could not make a right triangle. Now, they might be okay to make a triangle, might be acute or obtuse, but it's not going to be a right triangle. Okay, this example, find the missing length. Well, again, you want to pay attention to which side is my hypotenuse. I want to make sure I get that in the right place. So this one, we are finding the value of x, which is the hypotenuse. So sides that are 6 and 8, that's going to be my A and my B. Those are the legs. So 6 squared plus 8 squared would equal x squared. Okay, so 6 squared is 36. 8 squared is 64, and that would equal x squared. So 100 equals x squared. Okay, you're going to square root both sides. Hopefully this is a familiar one to you. 100 is a perfect square, and so square root of 100 is 10. So the length of that hypotenuse is 10. Okay, on B, this time we're missing a leg. That's X is representative of the leg, because over here 8, this is your hypotenuse. So when I set up this one, 6 is a leg, so it's going to be 6 squared plus X squared equals my hypotenuse squared would be 8 squared. So 36 plus x squared is 64. To solve this one, I'm going to move my 36 to the right side, and this becomes x squared equals 28. Okay, when I do the square root, well, square root of 28, that's not a perfect square. So x is going to equal square root of 28. Not a perfect square. Okay, but is there something I can do with that to simplify it? So what you're going to want to do is a factor tree. So I'm going to do a factor tree, 28. So 28 is 4 times 7. 4 is 2 times 2. Now I'm just going to bring down that 7. Okay, those are my prime numbers. So this square root of 28 could be written as 2 times 2 times 7. Okay, when you're simplifying a radical, you want to look for 2 of a kind. And we do have a 2 of a kind with my 2's. So my pair of 2's are going to come out front. Okay, so I have a pair of 2's that come out front. And then what's left over is my square root of 7. He doesn't have a partner, so he stays under the radical, whereas the pair of 2's were able to come outside. Okay, so if it's not a perfect square, this is called simplest radical form. And then that's how you do that one. Okay, so that is it for today. We're working a little bit on Pythagorean theorem. There's a worksheet that you will find for homework, and I think it's 4 questions dealing with the Pythagorean theorem. So please complete that and turn